So hello future achievers, okay, welcome back to this another amazing session, okay, and right now we have one of the most important topic, molecular formula, empirical formula, and there's one more formula also, structural formula, okay. Now see, molecular formula, empirical formula, that's what we need to understand for this session. Let's go through the definition and then we will also understand how do you calculate the molecular formula from the composition of the compound, right. I hope you have heard about those types of question. This much percentage of hydrogen, this much percentage of carbon, this much percentage of oxygen, tell us the empirical formula, tell us the molecular formula, right. Okay, that type of question we are going to do today. First of all, let's understand what is an empirical formula, okay. So, empirical formula is just the simple whole number ratio, okay. Doesn't matter however number of atoms are in your compound, you just have to take the simple ratio and then represent all the atoms with that number. For an example, if we have glucose, right, glucose has 6 carbon, 12 hydrogen, 6 oxygen, okay. Now this is the normal formula, okay, but empirical formula is after taking the ratio. So it means C is cancelled by 1, H is cancelled by 2 and oxygen is cancelled by 1, it means CH2O. This formula is the empirical formula. So the simplest whole number ratio of atoms in a compound is being told by the empirical formula. That's it. Nothing else is to study about this particular point. Key point is that it shows the relative proportion and not the actual number of atoms. Remember, it tells you the relative proportion. Compared to carbon, how many number of hydrogens are there? Twice. Compared to oxygen, how many number of atoms are there? Twice. It doesn't tell you the exact number of the atoms in that compound. Okay. Okay, now let's get back to the molecular formula. Molecular formula is just the simple formula that you are seeing. Formula of glucose is C6H12O6. That is the molecular formula. So molecular formula for sulfuric acid H2SO4. That is the molecular formula. Okay, molecular formula is one of the simplest formula, and it tells you about the exact number of the atoms in that compound. Okay, so whatever we studied, 6H12O6. This is the molecular formula and tells you, represents the true composition of the molecule and tells you exact number of atoms in that compound, okay. But it doesn't tell you about what? It doesn't tell you about the how these atoms are arranged. It doesn't tell you about the structure of that atom, okay. So that's why we have another formula, and that is known as the structural formula, okay. Structural formula will tell you the structure about the compound, okay. So for an example, how do we draw ammonia? We draw ammonia like this. Think about some structure in your mind. For example, we draw ammonia like this: hydrogen, hydrogen, hydrogen with 2 elements. Okay, this is the structural formula. Okay, and how do we draw H2SO4? Sulfuric acid. Tell me, sir. Sulfuric acid. This is how we draw. This is the structural formula of the sulfuric acid. This is the structural formula of ammonia. Got it? That's how we represent it. So a graphical representation that shows the arrangement of the atoms and bonds in a molecule. It tells you how the atoms and the bonds are arranged in a molecule. Got it? And the key point is that it illustrates the connectivity between the atoms, how the atoms are connected to each other. Okay. Now, example is compound is, for example, 6H12O6. So structure formula is a hexagonal ring with OH and H groups. Okay, these things you will study in the last sessions. Okay, don't worry about this thing. Okay, it will just tell you about the structure. Now let's get back to the one of the most important topic of today's session is how to calculate the empirical formula or the molecular formula from a question, okay, from the composition. Okay, so now let's get to the question itself. Okay, let's get directly on the question. Okay, a compound contains this much of carbon, this much of hydrogen and this much of oxygen. Okay, now we have this ratio by weight. Okay, this is telling us about the weight percentage, but it is not telling us about the number of compound. It is not being related to number of compounds. Okay, sorry, number of atoms. I want to switch this weight information into number of atoms information. Then how do I do it? I will just find the number of moles. But sir, the mass is not given, only the mass percentage is given. Then how will you find the number of moles? I am not trying to find exact number of moles. I am trying to find relative number of moles. Okay, so I will just suppose the carbon's mass to be 40 gram, 6.67 gram, 53.33 gram. That's it. Okay, now they have also told us about the molar mass of the compound is 180 gram per mole. Now to go from empirical mass to molecular mass, you have to utilize molar mass of the compound. Okay. Okay. So first of all, first step is to convert the percentages to the moles. Write down in your notebook. First step is to convert the percentages to the mole. Suppose you have 100 gram of the carbon, 100 gram of the compound. Then among that 40 gram will be carbon. Okay, 40 gram will be what? Carbon. Mass of hydrogen, suppose this, and mass of oxygen, suppose this. If you suppose that you have 100 gram of compound, this will be the mass of the carbon, hydrogen and oxygen. Okay. Then we have to calculate based upon this supposed amount of masses, we have to calculate moles. Okay. How do we calculate moles? Sir, given mass by molar mass. So given mass is what? 40, molar mass is 12. So this is the amount of moles. Same we calculate the amount of moles. Same we calculate the amount of moles. Now can you see something? Can you see something? The ratio of the moles. Now these moles are representing the number of particles. Okay, what do moles represent? They represent the number of particles. Equal to any number of particles. Got it? It means 6.67, 3.33, 3.8. Now this ratio is quite weird. Okay, because we cannot get any information about this particular thing. Okay, so that's why there is another set to simplify the ratio. Okay, we have to simplify our ratios. Now, how do you simplify ratio? Suppose 6.67, 3.33, 3.33, these are the three numbers that are given to us. You have to divide this number, these numbers with the smallest available number. So smallest one is the 3.33, so divide it with that number. Simple, simple, simple. Got it? So you will get 1, 2, 1. Now this ratio is in a simple whole number ratio, telling us that the carbon is relative to a number 1, hydrogen is relative to a number 2, and oxygen is relative to number 1. It means what? It means carbon is 1, hydrogen is 2. Is this the compound? No, this is the empirical formula. Okay, molecular formula will be in multiple of this compound. Okay, maybe like twice of this thing, thrice of this thing. Okay, twice the number of atoms in this, thrice the number of atoms in this thing. Okay, I have told you what is the molecular formula and empirical formula. Now the empirical formula is there. How do we find out molecular formula? For molecular formula, here comes the last step. Okay. Determine the molecular formula. Now we know that the total amount of mass in this particular empirical formula is what? Obviously, when you go from molecular formula, okay, when you go from molecular formula to empirical formula, what do you cancel out? You cancel out simple whole number ratios. Okay, it means you divide by some certain number. Okay, if we get to know that number, we can go back to this molecular formula. Okay, now what do you do this? How do you do this particular thing? Empirical formula is this. You find out the mass, that is 30 gram per mole, and we know that the total original mass of the compound was 180. It means the mass is divided 6 times to get out the empirical formula. It means if you multiply it by 6, multiply the number of compounds by 6, we will get the molecular formula or molecular mass. So, got it? We will multiply it by 6. So, CH2O. If you multiply by 6, then it will, instead of 1 carbon, there will be 6 carbon. Instead of 2 hydrogens, there will be 12 hydrogens. And instead of 1 oxygen, there will be 6 oxygen. And that's how we find out the molecular formula of the compound. Okay, and you will be able to get do all the question, and the steps are going to be very similar. Okay, I will say not similar, exactly same steps. Okay, and this is one of the important topic. You do get questions from JEE Mains, NEET, and in this competitive exam out of this topic solely. That's it. Okay, so this is one of the easiest topic that you should cover because it comes for board exams also. And I think that is it for today. Take care. See ya. Bye bye. Have a nice day. Keep studying.